This is section 2.1, What is matter? Here's the objectives. First one, define matter and explain how it's composed of atoms. Explain the differences between substances and mixtures, and then how we can classify mixtures as homogeneous, heterogeneous. Be familiar with chemical symbols. Be able to write formulas. Determine the number of atoms and name of each compound or element in a compound. So quite a few different things, but we'll kind of get over this pretty quick. So anyway, matter is just anything that has mass and takes up space. So anything in here, anything in those things is matter. Whether it's whether we're talking about a solid like a skateboard or a pencil, or liquids or gases, doesn't really matter. All of that's matter. Has volume, has mass and volume, or I always said it has mass, takes up space. And all of the matter is made out of atoms. So that's kind of the basic building block is an atom. And so everything that we know of, all pieces of matter, are made out of atoms. We're going to divide this matter into two main substances. We're going to call them mixtures and then pure substances. And so you can kind of see on this chart, we got pure substances here, mixtures here. We've got our different two main types. Mixtures are usually considered to be physical combinations, or sometimes called physical blends, of two or more different substances. So we mix two things together. Like in the lab we did sulfur and iron filings. We mixed them together. That's just a mixture. Or you did salt and sand. Those are examples of mixtures. A pure substance, on the other hand, is matter that has a constant composition. And we can be talking about things like copper, or we could be talking about a compound like sugar or anything like that. Those would be examples of substances, pure substances. Now, we can take substances and we can either say that they're homogeneous or they are heterogeneous. And so let's take a look at substances that don't mix evenly. So if you look at this one, it looks like it's got some oil and water, or like when you did the mixture with the iron and the iron filings and the sulfur, or the sand and the salt, they weren't perfectly even throughout. It wasn't the same. If you looked at it under a microscope, you could still see the different pieces. They'd all look different. That's what heterogeneous is. Heterogeneous is when things are different throughout. It's not the same. It's not a constant composition everywhere. Homogeneous substances, on the other hand, everything is the same. So if you have looks like some tea or something like that, that's an example of something that's homogeneous. Homogeneous is the same. You could look at any one part of it and it would be the same. A lot of times we call those things solutions. So like if you're making up Kool-Aid, and you put in the sugar and the Kool-Aid and you mix it all up, it all dissolves. And if you look at any part of it, it looks the same as any other part of it. So like I said, a lot of times they're called solutions. And then we have pure substances. So we had mixtures that we were talking about. Now we're talking about pure substances. One of those could be elements. And an element would be something that has only one type of atom. So we could be talking about hydrogen. We could be talking about oxygen. We could talk about sodium. We could talk about chlorine. And it doesn't really matter whether we're talking about whether things are single or they have multiple things to them. Like hydrogen always exists as a hydrogen bonded to another hydrogen. So it's always H2. Or if we talk about sulfur, a lot of times there's 8 atoms together. But it's just one thing. It's just sulfur. It's just hydrogen. Or we could be talking about single things like sodium, which is just one thing, one atom. But all of those are elements. Those are known as elements. Compounds, on the other hand, are ones that are made up of 2 or more atoms, and they are completely different from what you started with. So take a look at water. It's made from hydrogen, which is very flammable, oxygen, which really makes things burn, and then you get water, H2O, which doesn't burn. In fact, it tends to put out fires. And so you can see that the properties are completely different. Or you could take sodium metal, which is a very dangerous metal. It's very reactive. It would react with water and it starts to burn. It's just that reactive. You could take chlorine gas, which is a poisonous gas. You can mix those together and you get table salt that you put on your food. So you can see that the compound is totally different than what you started with. Okay, but these would be compounds. Elements, individual atoms, just one atom. Compounds, 2 or more atoms combined together. And if we have those compounds, the smallest of that, if we get just the smallest particle we can get, we call that a molecule. So we're thinking of water. The molecule is H2O. There's a hydrogen, there's an oxygen, there's another hydrogen. They're bonded together. H2O. That would be a molecule. If we're talking about salt, salt is sodium chloride. So we've got a sodium, we've got a chlorine. They're bonded together. Okay, and that's the simplest thing that you can get. And all of those symbols names and symbols are located on the periodic table. So if you look at any periodic table, you should be able to see those. And you can find periodic tables just about everywhere that you need them. But notice that we've got some that, hey, these are just single elements. So we got B for boron, C for carbon, or just single letters, I should say. But then there's also some that have two letters, like He for helium or Ne for neon. And notice that if they have two letters, that the first one's capitalized and then the second one is small. And this is important. I will count them wrong if you don't write it that way. So if you say, hey, I always write my E's like this, that's fine, but you're going to miss it. Make sure that the second letter of all of those elements, if there's a second letter, you write it as a small. And don't do this. Don't write, that. Don't write it like that. Write it as a small letter E, not a capital E just written small, but a small letter E, or whatever it is. So for each one of these, it's very important that you do that, because there are some differences. For instance, if I have a compound, or if I write CO, or I write C with a little o, I'm talking about two different things. This is carbon monoxide, and this is the element cobalt. And so there's a big difference. There can be a big difference between what the compound is, or what the thing is, depending on how you write it. So it's very important that you write these in the correct way. And we also use those symbols to write formulas for compounds. So for instance, if we wanted to write water, which is we know that it's H2O. Well, what are we saying here? This little number, this is a subscript. Okay, make sure you understand that when we talk about subscripts. So that's a subscript, and it says, hey, whatever's right in front of it, whatever symbol is right in front of it, there's that many. So it's saying I've got two hydrogens. Notice there's no subscript here, and that is always just assumed to be a 1 then. We don't write the ones, it's just an assumed thing. And so here we have two hydrogens and one oxygen. But maybe we have something like this. We could have AlCl3. Notice that one of the ways that we tell they're different elements is by the capital letters. So there's a capital letter and then a small letter. So I know that that's just one element. I know that this is an element, Cl. But this little 3 says, hey, there's 3 of these and 1 of those. Sometimes they even use parentheses. So sometimes they might have something like this. You might have Mg parentheses OH2. And we'll get into this a lot more later, but this is telling you that there's 2 of whatever is in the parentheses. So if you look at the parentheses, it looks like there's an O, oxygen, there's an H, hydrogen, but we've got this little subscript here. It says there's 2 of them. So really we have 2 O's and we have 2 H's. And we have just 1 Mg. This 2 does not go here. Nope, doesn't go there. Just like this 3 doesn't apply here. Okay? The subscript only applies to the letter just in front of it. None of the other ones. Okay? One of the ways that we can tell the difference between whether something is a substance, compound, or a mixture is by its composition. There's something called the law of constant composition, and that says that when we have a compound, it always has the same ratio. So if we're talking about H2O, talking about water, water is always 11% by mass of hydrogen and 89% by mass oxygen, always. On the other hand, if we have a mixture, like if you have something that you might not be sure, like if you have something like brass or bronze which are actually alloys, they can have variation. They can have different amounts of copper. I think brass is like copper and zinc, and they can have different amounts of those. So like maybe one time you have 65% copper, 35% zinc, but you can make another version of that, and maybe it'll be 90% copper and 10% zinc. And they're not compounds. Those are actually mixtures. Even though they look like it's the same everywhere, it's actually a mixture. So law of constant composition simply says that all compounds will have the same composition all the time, no matter where you get them. And we've talked about this already. I talked about the formula for a compound uses symbols to indicate the number of atoms, uses subscript to indicate the number of each ones. We talked about the parentheses. Be familiar with that. So, make sure that you understand what this is. Let's say that I've got the formula Mg parentheses NO3 2. Okay, take a look at that. Remember what I said. If the number, that little subscript's outside the parentheses, it's like taking it times everything inside there. In other words, it's just like in algebra. You've got a number outside the parentheses, you take it times everything. You distribute it over everything. Well, inside the parentheses, we have one N and we have three O's. So really, in this compound, there would be one magnesium. There would be two nitrogens. But there would be 6, 2 times 3, oxygens in that compound. Okay? And there you have it. All right.